When we convert vectors from rectangular to polar form, we express it as r angle theta in polar form. Theta must be expressed as an angle between negative 180 and 180 degrees. So we measure the angle theta from 0 anti-clockwise. This is the positive direction. The negative direction is the clockwise direction. So it's always a good idea to draw a vector diagram and work out which quadrant your vector lies in. Is it quadrant 1, 2, 3 or 4? So you can make sure the angle is correct. Further examples. Vector A is 2, 4. So because 2 and 4 are both positive, vector A lies in the first quadrant, so it doesn't add any more complication here. 2 along, 4 up. But just to check, draw a vector diagram anyway. We work out r using square root x squared plus y squared. So it's square root 2 squared plus 4 squared. R equals 4 plus 16, or it's the square root of 20. We can write this as 4.47 if we like. Theta, measured round from 0 anti-clockwise, is the inverse tan of y over x, 4 over 2. Therefore theta is 63.4 degrees. And it lies in the first quadrant, so this is the correct angle. So the vector A can be expressed as 4.47 angle 63.4 degrees. Vector B is negative 3, 4. So because one of these numbers is negative, B does not lie in the first quadrant. So we'll plot negative 3, 4, negative 3, 4, negative 3 along and 4 up, so B lies in the second quadrant. Angle theta is from 0 anti-clockwise around here. So we know that the angle we're looking for is between 90 and 180 degrees in the second quadrant. Start off by finding r. Negative 3 squared plus 4 squared. Now be careful, both of these numbers will be positive, as a square is always positive. Negative 3 times negative 3 is positive 9, plus 16, square root 25, r equals 5. Here we have the inverse tan. Now it's safest to use y over x, but use the positive numbers, 4 over 3. This means we get tan, inverse tan is 53.1 degrees. So to calculate our angle, we have to take this away from 180 because it's the second quadrant. 180 subtract 53.1 to get the second quadrant answer, which is 126.9 degrees. So our vector B is equal to, oops, I forgot to write 5 here, 5 angle 126.9 degrees. C is -2, -5. So because these are both negative, we'll have to pay attention carefully to the quadrants. -2, -5, -2, left 2 and down 5. Put C in the third quadrant. This means we're looking for an angle which is negative, round like this. So because we've gone clockwise from 0, it'll be a negative theta angle. But bearing that in mind, we'll work out r first. R is the square root of -2 squared plus -5 squared. So r equals 4 plus 25 square rooted, 29. Then we can work out theta using inverse tan. Just put the positive values, 5/2 for y over x. And that gives us 68.2 degrees. But this 68.2 is the amount, or the size of this angle in red. So we really need this blue part here. So we know it's between -90 and -180 degrees. That should be where our answer falls. So that means I take -180 and add on 68.2 for our final angle, which is -111.8 degrees. Final answer is 29 angle -111.8 degrees. Vector D is 5, -12. Draw a vector diagram of where this falls, 5 along and 12 down, so this is in the fourth quadrant. So it doesn't matter if your diagram of the vector is not too accurate. It's just really to find out which quadrant it goes in. That's the fourth quadrant. And this angle that we're looking for will be a negative angle, and between 0 and 90. -90, I mean. So we'll go back, work out the magnitude, 5 squared plus -12 squared. So it's the square root of 25 plus 144. So r is the square root of 169. R equals 13. Over here we do the inverse tan of 12/5, which gives us 67.4 degrees. That would have been the angle up here in the first quadrant, so we're needing -67.4. Because it's its mirror image. Instead of 67.4 that way, we've gone this way, negative. We have 13 angle -67.4 degrees as our answer.